take this problem. A pentagonal lamina of edge 25 mm side is resting on HP with one of its side such that the surface makes an angle of 60° with HP and the edge on which it rests is inclined at 45° to VP. Draw its projection. Okay. See, in this problem, same as usual, we have to note down our first position, second position and third position conditions. Okay. So come to the first position, it's the initial position. Okay. So here you have to see this problem is based on which type of surface or which type of lamina or which type of plane. So here given a pentagonal lamina. So this problem is based on the a pentagonal lamina, so that you will get 5 points A, B, C, D, E. Total 5 points you will get. Clear? First thing is clear. It is based on the pentagonal lamina. Next, whether it is resting on HP or VP. So here it is resting on HP. So that you have to start with the top view first. So it is clear. Okay. So which view you have to start? Top view is first you have to start. And the third one is whether it is a edge condition or corner condition, that you have to take care. So here they given clearly edge condition, edge of 25 mm. Okay, so that it is an basically it is edge condition. So based on these datas, so we have to easily construct the first position. Clear? So the first position is clear. It's a pentagon with the edge condition, and you have to start with the top view. So first position is over. And second thing, so basically it is based on HP, so that the second position inclination with respect to HP you have to write. Clear? So that HP inclination is 60. So in the second position you have to write inclination for HP. And in the third position you have to write for VP inclination. And in the third position is a reconstruction position, and whether you have to go with a normal or corner condition. And here it is clearly states that the resting edge is inclined, so that you have to go with the normal method. There is no locus method, because if there is a perpendicular bisector, in the problem they given perpendicular bisector, then we have to go with the locus method. But here there is no perpendicular bisector, so that only edge is inclined for VP, so normal method. So these things you have to take care, and based on these data you have to construct first position, second position and third position. Okay, first step is you have to draw the XY line, and you have to indicate VP and HP. Okay, that's the first step. And the second step, you have to construct the given plane, that is what, pentagonal of 25 mm side. And here it is a edge condition. From the data it is clear that it is an edge condition. And I will show you how to construct pentagon in manual method. Okay, in manual method. So first draw a edge condition in the left side, because why we have to go with the left side means we are resting on left side, that's why left side we are considering. If it is resting on right side, then we are considering right side, but in the all the problems in your prime book they consider left side, so that better you have to consider left side only. So 25 mm, then and draw. So next thing is you have to draw a angle from here to here is 72 degree, outer 72, or from here to here is 108. So whichever one is convenient you can take. So place the protractor and mark from here to here. Okay, so from here, okay, placed here vertically, and you have to mark. Okay, the angle is 90 minus 72, that is what, 28. You have to mark 28. So length is same 25 and the angle is 28, you have to mark. So from here it is 28, or from, if you take from outside it is 72. So anyone you can consider. And similarly here also same thing, the angle is from here to here is same, it is 25, and the angle is minus 28. Then take the compass placed here, then 25 mm and cut the arc, and same here, radius and cut the arc, and you can join. Okay, so this is what the a manual method. And in the software, just take how to construct in the software. First, length is 25 mm, then angle is 0, then 25 mm, the angle is 72 degree, then 25 mm, the angle is 72 into 2, then 25 mm, angle is 72 into 3, then 25 mm, angle is 72 into 4. Okay, so this is what the construction in the help of software. Okay, and once we construct it, then you have to select this, select and rotate option, rotate, and there is a fixed point and there is a rotating point. If you want edge condition like this, you have to rotate. Okay, see, now it is a pentagon with edge condition. Okay, so you can place it. Hello. So I will show you once again manual method of construction. So first take 25 mm. Okay, the length is 25 mm and place vertically, then placed here and place your protractor, and this angle should be 72 minus 90. How much this angle should be? So 25, and this angle 90 minus 72, that is the angle. Okay, and same here, placed here. Okay, and 25 mm same, and this angle is 90 minus 72 minus 18 degree, that you have to place, and take this arc. Okay, so from your compass, radius is 25 mm, cut 25 mm, and from here placed again, and take that 25 as a radius of that compass, and again cut the another arc. Then take the line, okay, and placed here and join. So this is what the manual method of constructing a pentagon with edge condition, and previously I showed with the help of software how to construct. So this is what the construction in your with the help of scale, pencil, protractor and compass. And if you want, you can check the dimension. See, it is a 25 mm, and this angle should be this is 72. Okay, this angle is 72. This angle from here to here angle is see, this angle is 108, and this outer angle is 72. You can cross verify. Clear? Okay, so once the construction is over, next you have to, what you have to do is you have to project it for front view. Is it correct? The same method what we follow in the square as well as in the then give naming. So you will get a 5 points. This is a A, this is a B, this is a C, this is a D, and this is E. And after that, take the same line and draw the front view. So front view. Okay. Then give the namings. If you see from the front, this A is visible, means A dash is visible, and E dash is not visible, and B dash is visible, and D dash not visible, and C dash is visible. So this is a first position. So for the second position, take the scale and measure it. It is 23.78 and this is 14.69. Okay. Then take the line and placed on XY line, okay, and this inclination should be given in the problem of 60 degree. It is of 60 degree. So take this, okay, and draw a 60 degree. The length is 23, okay, the length is 23, or else you can take the distance between this to this is 38.47, and take the a line and draw angle is 60 degree, okay, and so draw a line, okay. Then take your compass, and from here the first point is from A to B is 23.78, okay, cut the first arc. And second thing, from the same point, okay, so the next point C dash is 38.47, okay, and cut another arc. This is then one method, the manual method. I am explaining the manual method, okay. So from A dash to B dash is 23.78, from A dash to C dash is 38.47. This is the one method. Or else you can directly take B dash to C dash, that is 14 point. From here to here you can cut 14.69, whatever. So whichever one is convenient, you can go with that one, okay. Either from A to B or B to C, or from A to B or A to C directly you can cut. So any method is correct. You just use your compass. And after that, once the front view is over, okay, and then you have to draw top view, okay. So the top view should be exactly coincide, it should be coincide, okay, like this. And the last one is, okay, and also you have to represent their names, the same names. Here we, okay, we rest on left side so that A dash is visible, say the same line but it is of 60 degree, and B dash visible, D dash not visible, and here C dash, and this angle is, it should be 60 degree, okay. Next, so next what you have to do is, with respect to, okay, points, same point, first consider A point. I want to mark A point so that A is here and A dash is here, so it should be A and A dash should be coincide, first point. Then B is here and B dash is here, then C is here, C dash is here, then D is here, D dash is here, and E is here and E dash is here. So like this you have to mark all the points and give naming. This is an A, this is an B, C, D, and E. Once the naming is over, you just join from A to B join, B to C join, C to D join, D to E, okay. So like this you have to join. This is what a second position, and here you have to show the arrow mark so that, so where to where we project. So this is a downward projection, okay, and here upward projections, and from here left to right projections. So this is what the a second position. If you draw up to second position, you will get 1/3 marks, okay. So in the third position, in the problem they given, okay, just read that third position. The rest, the edge on which it rests is inclined 45 degree, means this is an edge, okay, A to E is the edge resting, is it correct? This edge is rested, and this C is, we are going to rotate up 60 degree. So this edge is inclined of 45 degree, it is inclined of 45 degree, okay. so that this edge is 25 in the first position, the same edge is 25 in the second position. See here. So that we have to go with the normal method because there is no change in the dimension. But if you consider a perpendicular bisector or any other edges like ED or DE or BC, these edges are changes. In the first position is somewhat 25 and second position is less than 25. Okay. If the inclination is with respect to these edges, then you have to go with the locus method. But in this problem or most of the problem they given the same resting edge is inclined. The same resting edge is inclined. So here also same 25 and here also same 25. So that we have to go with the normal method. We won't find any alpha or beta. Clear? Directly draw the 45-degree line and rest this edge. Is it clear? So when we go with the locus method means there is a change in the dimension, then only we can go with the locus method. But here there is no change in the dimension, so that we are going with the same normal method. So first we draw a 45-degree line. Okay, you just draw 45-degree line. So take your compass, okay, sorry, protractor, and place here, then draw 45 degree. So this angle is 45. Clear? This angle is 45. Then what you have to do is, so in the software, say directly we copy this. Okay, so like this we are going to copy and move option and just move this, then rotate. So this is the first point of rotation and this is the second point of rotation. Like this we are going to reconstruct. That is in the software. But in the manually you have to reconstruct with the help of a compass and with the help of scale. Okay, you have to reconstruct. First thing, measure this 25 mm. First place the resting edge AE. So 25 mm is there. So first you have to place 25 mm. Okay, so place 25 mm exactly on the 45 degree. So with the help of scale and pencil, mark 25 mm. So wherever on this 45 degree line, the length is 45 and placed. Okay, so after placing you just name it. This is an E point and this is an A point. Is it clear? So just I am going to rotate this 45 degree so that EA it is on 45 degree line and this B, C, D are above the 45 degree line. So not below. So you have to construct here just 45 degree. Or else if you want you can of course you can draw 45 degree line like this. Okay, and you can reconstruct. So that method is also correct. So next what you have to do is you just with the help of compass you just measure all the dimensions. Okay, so here I just measured 14.18 and 21.52. These are the dimensions of these lines. Okay, and I take the R and from means take your compass, mark a 14, so 14.18 radius and cut the arc. Similarly from here same length is there, 14.18, cut the arc from your compass. Next, okay, so next is either you can measure the angle or you can take cross distance from A to D. So from A to D, what is the distance? Either you can take the distance, okay, or E to B, what is the distance? Okay, so from here compass placed here and okay, you just measure what is the distance. So it is 14.34.82. Okay, so like this you can take, so compass placed on A and mark up to D. Okay, it distance is 34.82. so like this. Okay, so and from here same 34.82. So placed here, okay, 34.82, and cut the arc. So like this you have to cut the arc, and once you cut the arc you will get an point, intersection point. This point is there, okay, and that point you have to join, and here there is an intersection point between these two, and join here. And after that, and next you need a point C, and you just mark this one is a B and this one is a D. Okay, now I need a point of C, so take this same center. From here you have to cut the arc of 21.52. so cut means in the compass placed on B and mark C, okay, then cut the arc, and similarly from the D point and the same 21.52 and cut one more arc, okay, and finally join. So finally join this point from here to here. Okay, and similarly from here to here. So I name it, this is a C point. So this is what A, B, C, D, E is the reconstructed second position top view with the help of compass and scale, okay, and after that we just remove these dimensions. Clear? And once you got this top view, then go for the projecting of front view. So from A, first you just project these horizontal lines, okay, and here first A is here and A dash is here. So first mark A dash. Next B is here and B dash is here. Mark it. Then C is here, then C dash. Then D is here, then D dash. Then E is here, then E dash. Like this you have to mark, then remove. Okay, and name it. This is A dash, B dash, C dash, D dash, and E dash, and finally join. From A to B you have to join, B to C you have to join, C to D you have to join, D to E, then finally A. Closed it, and you have to show the arrow mark. So I am always, it is left to right we are going to project. Okay, so this is what the final position of front view and top view. So this is a first position, and this is a second position, and this is a third position. So first position always pentagon with a edge condition, okay, and it is of 25 mm, and top view first because resting on HP. Second position is HP inclination because of resting on HP, so that second position HP inclination. And the third position is VP inclination, okay, and it is normal method. Why? Because the same edge is 25 mm, in the second position same edge is 25 mm, so in the third position the same edge we are going to rotate, so that it is of normal method. Okay.